everybody, welcome back. This is Unit 7, Lesson 2, and in this unit today we're going to talk about calculating percent composition. Alright, so when we calculate percent composition, it really depends on the information that they give us as to how we calculate it, because sometimes they give us lab data like what we did in class today where we found the percent water, and other times they give us a chemical formula. Okay, so either way, we're always going to use the same composition for percent by mass, and this is the equation that's given to us in reference table T. It's equal to the mass of the part, and the part is whatever they are asking you for, divided by the mass of the whole, which is, of course, if they give us the formula, it's the formula mass times 100. Okay? So again, this equation is given to us in table T. And it's under percent by mass. It allows us to calculate the percent composition. Okay, so this is what you're writing in your box. Okay, you're writing all this stuff in the box. Okay, so again, sometimes they'll give us lab data, and we'll talk more about that when we actually do the lab. We'll debrief on the lab tomorrow. Okay? So, a couple of examples. You have this one, I believe. This is number 1. Which compound contains the greatest percent oxygen by mass? So what we will need to do when we do this question is we will need to find the percent in each compound. And then, of course, we want the greatest. So whoever is the biggest will win. So I'm going to take each compound kind of separately, right? We have NaClO, okay? The percent oxygen will be equal to the mass of oxygen in the compound. That's your mass part, right? Divided by the mass of the whole compound, which is your formula mass, times 100. Okay, so we list our elements just like last night when we watched our video and count. We have one Na, whose mass, again, on the periodic table, remember where I'm getting mass, right? Right here. I round that to the nearest whole number. Okay, but its mass is 23. So that gives us a mass of 23, okay? And then we have one chlorine, whose mass is 35. And we have one oxygen, whose mass is 16. I'm getting all of those from the periodic table. So I add those values up. Again, hopefully you have your calculator handy. If not, do it old school. Add it long way. Which gives you a formula mass. That's your formula mass right there. It's your mass of your formula of 74. So my percent oxygen then is the mass of oxygen in the compound, 16, divided by the mass of the whole compound times 100. And we get 21.6%. Okay? So I know that this is 21.6% oxygen by mass. That's what it's telling me. All right, so letter B I'll do down here. We have H2SO3. So we have H, we have S, we have O. There's 2 atoms of H, each with a mass of 1. 1 atom of sulfur with a mass of 32. And 3 atoms of oxygen, each with a mass of 16. So I add those up, and I get 82. So my percent O is equal to 48 out of 82 times 100, which gives me 58.5%. Wow. Well, that guy And then for letter C here, okay, I'm just going to erase this so that we have some space to do letter C. For letter C here, I like to consolidate the formula first, so I think it's easier to write this as C3, H5 and 1, 6, O2. Those are really the same thing, right? So carbons we have 3 of times 12 is its formula mass. 3 times 12 is 36. H's we have 6 of, its mass is 1. And O's we have 2 of, whose mass is 16. So we add those up. And we get 74. So my percent oxygen in this last compound is 32 divided by 74 times 100. And that gives us 43.2%. So the one with the greatest percent mass is this one. Notice, even though it worked out this time, okay, to be the one with the most oxygens, it won't always be that way, okay? So it's not always the one with the most oxygens. That's important to know. Okay, you have another example in your notes, right? It is on the next page, on page 3. It says, determine the percent water in MgBr2.6H2O. So I'm just going to erase this here. Okay? And we'll do this as example number 2. Now this time they don't want the percent oxygen, they actually want the percent water. But it's the same idea. That will be equal to the mass of water in the compound divided by the mass of the whole compound. Again, since I have the formula, that's the formula mass times 100, right? Okay? So we have to find the formula mass of this compound here, this crazy hydrate, right? Just like our lab, that crazy hydrate. Okay. So we have MgBr2.6H2O. Remember, the dot is the symbol for a hydrate. And it really just means attached. So instead of, it doesn't mean multiply. So just change it to a plus there. It's like that and that. It's like that with that attached. So we list our elements. We have Mg. We have 1, and magnesium's mass is 24. Bromines, we have 2 of, and its mass, oh, I don't know that one. I think it's 79. Let's look it up on the table real quick. Bromine, yep, 79.9, which will round to 80, won't it? Okay, so bromine's mass is 80, which is 160. And we'll add those together to get 184. But we're not done, because we also have 6 waters. So we have hydrogens. Remember, you have to distribute. Distribute means multiply. So 6 times 2 gives me 12 hydrogens, each with a mass of 1, for a total of 12. And oxygens we have 6 of, right? 6 times 1 times 16, which gives us 96. And then we add those up to get 108. So the formula mass of the whole compound, 184 plus 108, gives us a formula mass of 292. Let me just erase this so you don't get confused here. Okay? You add those together, right? So then the percent water is pretty easy to find, because I have the mass. This is the mass due to water, right? That was the mass of our 6 waters that we found up here. So that is equal to 108 over 292 times 100. Okay? So 108 divided by 292, whoopsie, sorry, forgot to clear the calculator out, times 100. And you get a 37.0 if you round it, percent water. Okay, unlike our hydrate that we used today, that was 36% water. Okay? All right, that's it for tonight, everybody. Enjoy your evening. Have a great day, and we'll see you tomorrow. Bye-bye.